Hello everyone, welcome to the Recreational Astronomy Night meeting of the Toronto Centre RASC. My name is Paul Markov, I'll be your host for this evening as usual. Hello also to our viewers on YouTube. We miss you here in the meeting room. We have lots of space for you. Perhaps you can join us next time in person. So we have our usual 3 speakers for this evening, and the sky this month will be presented by Denis Gray. Denis is running a little bit late this evening, so he will not be kicking off the presentations tonight. Instead, we're going to start with our second speaker, who's going to be Chung, and he'll talk to us about what you never knew about cleaning optics. Now, Jim was supposed to present about imaging emission nebula with a new type of filter. He will still present that, but it'll be at the November meeting. Our third speaker is Adrian Aberdeen, and he'll talk to us about quality astrophotography on a budget. And then we'll have Chou, our president, deliver the announcements for this evening, and that'll wrap it up. Show of hands, do we have anybody here who's attending for the first time? Member or not? Not tonight. Everybody has been here before. Okay, very good. So you know how it works. Okay, I think I've covered everything. Quick question. Is anybody selling calendars, RAC calendars this evening? Yes? Who's taking care of that? We have calendars, but not a seller. Nobody? Ah, John. John is going to take care of calendar sales at the end of the meeting. And how much are they? $15. It's a bargain. Is the price going down? It's the same, okay. I remember I used to pay 18. It's going down. Very good. All right, so let's get on with our presenters. Chung, he's first up.
Okay. Anytime you let me know when you're ready. Good. Okay. Well, thank you everyone for coming out this evening. As you can tell, I gave this talk almost more than 4 years ago at the DDO. It's kind of a small audience, so I thought maybe I'd recycle it for the general membership to listen to, and they might get something informative out of it. So I'd like to share some insights on when and what to use to clean your optics. So this won't be a how-to talk because there's lots of YouTube videos that show you how to clean your optics. So telescopes are fairly expensive, and like most owners who own expensive things, they want to take care of them. But the common sense notion to keep your optics pristine and clean is actually wrong. We shouldn't be actively cleaning our optics, and we're likely cleaning the wrong optics and in the wrong way. So in this cartoon here, Fergus, in his overzealous cleaning of his reflector mirror, has worn off that thin aluminized reflective layer and turned his mirror into a lens. The same thing can happen to a refractor. If you clean your refractor objective lens too much, you run the risk of wiping off those very important anti-reflective coatings. So in Harold Suter's famous book, he talks about the effect of dirt and scratches on optical performance. So there's dirt and scratches cause generalized scattering of light, and the effect is mainly seen when you're looking at bright objects like planets, and it causes low contrast details to become washed out. So in other words, dirty optics really has a negligible effect on your telescope, because don't forget that telescopes already have to contend with huge obstructions like the spider veins of a secondary mirror or the central obstruction of the secondary mirror itself. So if, oops, okay, that's right. Yeah, this is a simulation of your 8-inch Schmidt-Cassegrain corrector plate. So according to Suter's math, as long as the dirt is less than 1/10 of 1%, of the area of your optics, you can ignore it. So that's, in this case, is 30 square millimeters, or about a pinch of salt. But realistically, you can probably throw a teaspoon of salt onto your telescope and it won't matter. Because don't forget, you won't see these things because they're not at the focal point. You only have to worry about dirt that accumulates closer to the focal point. So in other words, you need to clean your eyepieces, your Barlows, your focal reducers, your diagonals, which in a reflector is your secondary, any filters that you have, and if you're an imager, your camera sensor. And this is what a dirty camera sensor looks like. All those dust motes will have a real effect on your image. So the best defense, or the best is a good defense against dirt, is to store your eyepieces with end caps on both ends, or put them in eye bolt cases. And you've got the equivalent for your Barlow and your diagonal as well too. So when you're not using them, store them this way. Some of you who have those small, high focal length eyepieces, which come with a very small eye relief, will have to clean their eye lenses a lot because they'll accumulate a lot of eyelash oil and grime. And diagonals are also made to be taken apart and cleaned regularly as well. So the question is, why can you clean these guys so often, but you can't clean other parts of your telescope that often? So traditionally, the thin aluminum reflective layer of a mirror is made by evaporating aluminum with either heat or electron beam in a vacuum chamber, and it just passively disperses and deposits onto the glass mirror surface itself. So this forms a very porous, very weak, not a very dense layer that's very easy to damage if you don't wash it carefully, and as a result, you should wash it very rarely. So the reason why you can clean your eyepieces, especially the eye lenses, is designed probably without coating, so that you can clean as much as you want without having to fear rubbing anything off. The diagonal is a different matter. Most modern diagonals are not made with that aluminum reflective layer. They're made with these dielectric coatings. So these are alternating metal oxide layers of different refractive indices, and there's literally hundreds of these layers. And they combine to give you almost 100% reflectivity and a very, very hard surface. So you can clean this every single day and it's not going to damage it. So the question remains is that why don't we coat mirrors with this method? The problem is that each layer has to be absolutely uniformly the same thickness. Otherwise, you run the risk of altering the figure of the mirror. And the other problem, too, is that these coatings cannot be chemically stripped. They have to be ground off, so that would also damage your mirror if you wanted to ever recoat the mirror at some point in the future. This is just an interesting study I wanted to throw in here. This is an amateur astronomer, William Paolini, and he is also an eyepiece expert. He's written a book about eyepieces, and he did tests between the conventional aluminum reflective diagonal and prism diagonals versus these modern dielectric diagonals. And he agreed that the modern ones are much tougher and are much brighter, but they're not as accurate. When he views planets, for example, he loses a lot of contrast and detail because those hundreds of dielectric coatings cause the mirror no longer to be optically flat. So if you are a real intense visual observer, I would stick with the traditional aluminum reflective diagonal or prism diagonal, although these dielectric ones are very good for the average viewer. So there have been advances to make mirrors tougher so that you can wash them occasionally. So this method uses an ion gun to actually hit the aluminum layer and compress it further to increase its density. And if you include a stream of sodium monoxide with oxygen, you actually get an overcoat of sodium dioxide, which is quartz, and that makes it even tougher. Or essentially, sorry, silicon dioxide. And then the final method you actually, instead of evaporating the metal with just heat, you bombard it with really high-speed ions, and it gives more kinetic energy to the outgoing aluminum, and it strikes the glass mirror with even more force and causes an even denser, tougher mirror layer. So this, again, is also a surface that's easier to clean occasionally. Yeah, so this is sort of similar to putting your eyepieces in eye bolt caps. You have to always remember to use your anti-dew equipment, your dew straps or your dew shields to prevent dew and frost from forming. What happens is that this introduces atmospheric contaminants to your telescope, and it also cements any pre-existing debris that was already on that surface and makes it much even harder to remove later on. So the first step is always debriding the surface. And I would recommend using a soft brush or one of these air bulbs, which you can buy at camera stores. A lot of people use canned air, and that is not a good idea. There's lots of additives in the propellant, which you don't want evaporating onto the optical surface. And also, if you don't hold the can perfectly vertical, a full can sometimes spews out the propellant itself. And here's a little video demonstrating that. See, that's a propellant actually leaking out of the can. So that happens when you hold it more horizontal, obviously. If you hold it more vertical, it's less chance of that happening. There was an internet rumor that the temperature of the fluorocarbon in propellant is minus 100 degrees Celsius. If that were the case, you'd end up having microfractures in the glass and also in the coatings too. So I took a thermometer, so I was curious to see how cold it really was. It's only about minus 38, so it's not really quite that dangerous. So there's quite a few really popular cleaners. One from Zeiss, and there's no better company than Zeiss when it comes to optics. Optical Wonder is marketed by Bader Planetarium. And both of these have organic solvents to help dissolve the oils from fingerprints and eyelashes, and also an aqueous component to help dissolve any mineral contaminants. And then the third one is called Purosol. This is different. They advertise as being made from enzymes of plant extracts, which break the bonds between dirt and glass, and then reverse the charge on the glass to prevent future dirt from accumulating. And so in this day and age of health and safety, all you have to do is look at the manufacturer's safety data sheet to see what is inside these cleaners. As you can see, the Zeiss one is simply a 6% solution of isopropyl alcohol. And the Bader one is a mixture of ethanol and propanol. The Purosol safety sheet has nothing on it because there's nothing toxic in it. It's completely organic, completely eco-friendly. And as a result, it's very popular in environments where fire is a real problem because it's completely not flammable. So it's used extensively in NASA. So you can also make your own, because as you see, the Zeiss was simply a 6% solution of isopropyl alcohol, so there's really no need to spend the money to buy the Zeiss cleaner. You can make your own. But you just have to be careful picking the reagents. You want to pick something that's really pure. You can get stuff from Canadian Tire hardware stores, but generally those solvents are not very pure. They've probably got lots of contaminants in them. And of course, once they evaporate, they'll leave those contaminants behind. So a good place is the drugstore. So for example, Shoppers Drug Mart has 99%. This is like chemical reagent grade alcohol. And it's also a good place to pick up distilled water as well. So the Arkansas Sky Observatory has their own recipe, and it's listed here. The only component that's a little strange is the photo flow. And that's available at at Henry's. It's a surfactant. It reduces the surface tension of that cleaner recipe so that it wets the glass easier and also causes everything to evaporate faster. So the reason why this picture is here, there was a rumor, again, on the internet that there's something inside Windex that causes it to always leave smears. And this stuff might even be abrasive. I was curious. I said, is there really something in there? Because I personally don't like Windex, because every time I use it, it seems to always leave something on the glass. So I thought, let's centrifuge some Windex and see if there's something that's really insoluble inside the Windex solution. For those of you who don't know what a centrifuge is, it's a really important piece of biomedical equipment. It subjects a solution to high g-forces so that anything that's suspended in that solution is rapidly precipitated to the bottom. So I thought I'd make my own centrifuge. This is what is called a centrifuge bucket. It's what the centrifuged sample tubes sit in. And this is just material from an underground sprinkler system. I'm just weighing it to make sure they're approximately the same weight. And then I just tie them together to a piece of metal with a shaft that fits perfectly into my Dremel. And that's going into my sink with a piece of plexiglass covering it just in case something terrible happens. And there's some video here which we can watch. Oh, it's got sound, even better.
Scotty, I need more power.
Okay. Yeah, in this video here, I wanted to see how fast it was spinning so I could sort of use the math and figure out how much G was being applied to the solution. So this is an Arduino's strobe light, so I can figure out how fast it's rotating. Okay, so if you guys know anything about timing a car, you know you've got that strobe, and when everything stops moving, then you know you've got the frequency of the strobe is the same frequency as the rotation. So as it turns out, it's applying 9,000 G to the Windex solution. So I spun it for 10 minutes, and this is the result. There is something in the Windex. Probably not part of the Windex recipe, probably some contaminant from a dirty bottle-making factory. So I also spun some distilled water just to make sure it wasn't something from the centrifuged tubes themselves. That came out clear. And I filtered the Windex through a couple of coffee filters, and that also came out clear. So this is a good way to use Windex, is you could pre-filter it first before actually using it. For anything, you know, even your kitchen windows. So this was another little experiment. I wanted to see, sort of quantify how good these cleaners are. So I wanted to simulate atmospheric contamination on optics. So I've got a little ultrasonic humidifier and some Epsom salts, which is magnesium sulfate. I dissolve that in the ultrasonic humidifier. I picked up some surplus shed anti-reflectively coated optical windows, and then they're being blasted by the humidifier, and that's the end result. So this would simulate really, really bad contamination from dewing, repeated dewing cycles. So in order to quantify, I was gonna stick the dirty glass slide into a spectrophotometer, measure its transmission, and then stick it in one of the cleaning solutions for 5 seconds without agitating it, just let it sit passively in it, take it out, and then put it back in again and measure the transmission and see if there's a difference. Again, for those who aren't familiar with spectrophotometers, it's another piece of biomedical equipment. You introduce a monochromatic beam of light to a sample, and that light comes from a rotating prism or a diffraction grid. And then there's a photocell on the other end of the light to measure how much of that original light is actually transmitted. So instead of buying, you could buy one of these for less than $100. Certainly a used student spectrophotometer, but I frankly have too much junk at home, so I thought I'd make a sort of like a digital spectrophotometer. This is not a real one. It kind of simulates it because it doesn't really produce monochromatic light, but it does produce the whole spectrum of the light because there's an RGB LED, and by altering the components of the RG and B, you can simulate all the colors in the visible spectrum. So it's a really simple design. The sketch is really quite simple too. And this is it in action. You can see all the different colors that it produces. So it goes from all the red to purple. That was obviously at Christmas time many years ago. And so this is the Arduino. This is a block of polycarbonate where I glued the LED and the photocell across from each other, and I cut a slit where the glass slide would fit in. I just got some red celluloid tape in there just for a practice run. And then you have to cover everything up to make it light tight so that ambient light doesn't interfere with the readings. So you can see that it should be a nice flat transmission across the top, but it falls in the blue sector because the photocell is not as sensitive in the blue spectrum. And you can see the red tape that I put in there works quite well because it transmits in the red, but then by the time you reach green and blue, it starts to drop until it's 0 in the blue spectrum, which is the way it should be. So we've got, the first experiment was with pure alcohol. And as you can see, the dirty glass and the alcohol, which is the red and green here, are the same. So the alcohol really did nothing in terms of cleaning the contaminants off the glass. But the pure sol did really well because after 5 seconds, its transmission profile is very similar to basically clean glass. And same with ASO fluid, that homemade recipe. You can see that blue and green here are very similar. And lastly, I just want to introduce this last product here. It's called First Contact by Photonic Cleaning Technologies. I heard of this similar product years ago for cameras. It's a polymer that you paint onto your optics, you let it dry until it's a semi-solid film, and then you pull the whole thing off, and it's supposed to take all the contaminants that's on the glass away with it. Only problem is it's pretty expensive. This little kit is $100, and that's only enough material for an 8-inch mirror. So here's an example of it in action. After you let it dry, you can basically peel it off. And as you can see, it's not really that good. To be fair, probably it works better if you debride some of the major contaminants off first, and then as a last step, apply this material. So in conclusion, don't clean your telescope optics too often. Do clean your eyepieces, diagonals, Barlows, reducers, and filters. Don't use Windex unless you filter it through some coffee filters. 6% isopropyl alcohol solution is good, and it's really inexpensive. And I probably would not buy the First Contact, as it is rather expensive for what it does. And that's it. Thank you very much. Any questions? Or any online questions? Oh, at the very back.
What tools can you use, like Q-tips or would you recommend using, say, Q-tips dipped in the solution to clean?
That's probably what I would use for eyepieces, although I'm not an expert in actual cleaning per se. Like YouTube would have a lot of examples of people actually physically cleaning, optics and showing you the best way for doing that.
These are sort of a lens pen with the activated carbon. Are they any good?
I haven't tried one, so I can't tell you. I imagine they're probably okay, yeah, because if they work on cameras, which basically are telescopes of a sort, so yeah.
Do you need to use some special products when you deal with fluorite lenses?
I don't believe so. I don't think that matters. Yeah. Okay, thank you.
Thank you very much, Jim. You never cease to amaze. The length you go through to test stuff is amazing. Yeah, fantastic. Looking forward to your presentation.
Hello everyone, my name is Adrian Aberdeen, and the topic that I'm going to be presenting today is quality astrophotography on a budget. Some shameless promotion for myself. You can find me on Facebook and on YouTube at Balcony Astro Imaging. I just want to say hi to my son who's watching. Hi Ethan. It's almost time for bed, so get going. He's still my little apprentice. About a year and a half ago, I can't believe it's been a year and a half ago that I presented. He was helping me out on the balcony. He doesn't come out as much as he used to, but whenever it is that we have any outings, like there, for example, we were the picnic, the RASC picnic back in August, he was there at the DDO. So to begin, I have a huge update. I'm still on my balcony, and I'm not happy about it. That's a big update. And I'll tell you why it is that I'm not too happy about it. So shortly after my last presentation back last March of 2018, we had a massive windstorm that came through Toronto. And I had unfortunately left the telescope on the balcony. Thankfully, I took the scope itself off, but I left the mount on the balcony. And let's just say it took a tumble. So I'll play this little, yep, right here. And this is the sound that it makes. So anyone who knows about telescope mounts knows a sound like that is not good. So what happened is some of the bearings got, the teeth, the meshing, got a little bit out of whack. So thankfully I was able to have Blake and Jeff Booth help me out to be able to fix it. So I got it back up and running, and I'm happy to say it is good. What's not good, oops, is my next door neighbors decided to install LED lights all over the side of the building. So they moved from the sodium lights into LED. So I have 1, 2, and 3 that are now unfortunately straight coming at me on the balcony. So what I had to do was an ingenious solution, really, with a couple of friends of mine, Astro guys, who suggested coming up with a light shield, where I used some PVC piping here, and I used one small one and then one big one that fits inside of it, and then I just took a drill bit and drill some holes, so I can then adjust the entire thing up or down, depending on where in the sky my object is and where the LED lights are coming through. So I'm very happy that so far I've actually seen better quality in my pictures with and without, between with and without the shield. So I'm happy with that. So a disclaimer. Just so you know, anything that I mentioned, products that I mentioned in my presentation, I'm not affiliated with any of them. I don't get paid for any of them or anything like that. These are just my opinions, so take it as you will. So anyone who's starting off with astrophotography, some people tend to ask me, what would you recommend you start off with? Honestly, I would suggest you start off with something that's a small refractor. It could be a triplet, it could be a doublet refractor, but start with something that's around 80 millimeter. And I'll show you why, and I will show you why you don't want to make the same mistake that I did. And I wouldn't necessarily have a mistake, but I'll tell you what I mean by that. So this is 2 pictures that I took of the same object. This I took and I presented at my last presentation here of the M42, the Orion Nebula, the Great Orion Nebula. And this was in an H-inch SCT telescope. And this is the same picture in an 80 millimeter. And if you notice, the parts of the Orion Nebula is the same as we have in here. So the 80 millimeter starts you off with a much wider, bigger scale of field of view for your images. And that's the reason why I suggest an 80 millimeter, because it's very forgiving, both when it comes to your guiding, as well as how much more of an object you can fit into it. So if you're getting into astrophotography, you set a budget. I'm not going to talk about money, because everyone's budget is a little bit different. But what I would say is I would recommend someone who's starting off, start off with a DSLR camera and then work your way up. If you want to, then by all means you can go ahead and do an astro camera, an actual astrophotography camera, and those work really well. That's what I use myself. Also, you want something that is either a prime lens. So one of the lenses that you would use on taking pictures, regular pictures, for example. Some kit lenses work okay, but I would recommend a prime lens that is usually in around the 80 millimeter to 135 millimeter focal length for it. I prefer using a 135 millimeter, and I'll show you why. You can very easily put it on a tripod and get up to 30 seconds without major star trailing in your images. And then also if you use a tracking mount, then you can go a little bit longer when it comes to your exposures. Also check out, and I am a very strong proponent of using or buying used products. A lot of the products that I've used, I bought from the used market. my 88-inch telescope was used, my mount was used, predominantly almost everything that I'm going to be presenting on tonight that I've been using was used. So there's places like Astro by Cell, there's Cloudy Nights, there's Kijiji, and those kind of places where you can go and check out and look for used products. So what I settled on when I was looking to look into getting a wider field of view pictures is I realized that an SCT is good for certain things. A refractor telescope, let's say 80 millimeter, is good for certain things. But then I also like massive objects where you're looking at huge nebulas. And I just wasn't getting that with the 80 millimeter. So I said, how about I look into 135 millimeter? So I settled on the Rokinon 135 f2 prime lens. It's a very nice wide field of view. It's a great starter lens for someone who's starting off, and makes it perfect for if you're using anything like a star tracker. And I got this used on the market. So the way I have it set up is, in this part, I have it here with my DSLR camera, which is the same DSLR camera that I use for taking regular pictures. It's not modified or anything like that. It's just a normal camera. So this is what you get in when you go into the 135 millimeter range. So this is the same Orion, the same Orion complex that we were looking at just now, remember? Where we had the little piece up here. This is what you will get in an SCT. About this much is what you'll get in an 80 millimeter telescope. And this is what you're going to get in 135 millimeter. So I took this off my balcony. I processed it in March, but it took me a little bit, I think I was in January or February is when I actually obtained the data. And again, that is taken from a balcony here in Toronto in really light polluted skies. And actually it was taken, most of the color was taken with a DSLR camera, non-modified. So here we have the Seagull Nebula, and then down at the bottom, we have the little baby Thor nebula down here. If you were looking at this through an SCT, an 8-inch, for example, this is what you're going to see. Whereas the 135 gives you the entire Seagull and then some. And then this is here is the Flaming Star nebula that I imaged back in March. So the Flaming Star is right here, and then I figured the NGC on this. And then over here we have a star cluster. So say yes to new adventures. So late last year into early this year, I was presented as if I wanted to join council. And I said yes. I'm a member of the club, and I would love to be on council. So one of the things with council is some council members, tend to have a portfolio of things that they may be responsible for. So I got approached by Peter Richards, who asked me, hey, listen, you're coming out to a lot of the events that we have, both at Long Sault for our Dark Sky events, as well as the City Star Party. Would you be interested in taking over as the observant chair for the Toronto Centre? So I said, new adventure, sure, why not? But then I realized that I'm doing a lot more of astrophotography versus visual. I can't tell you the last time I actually looked through a telescope. So I said, I'm going to need something that is going to be more portable, that I can easily take out with me while I'm at Long Sault or the City Star Party. And I started looking around to see what options I may come up with. So the first thing is, anyone who knows about astrophotography is you want to make sure that the mount is the most important piece. Because if you don't have a good mount, you can have the most expensive objective on your mount, but it's not going to be good if you can't take long exposure pictures. So I wanted to make sure that it's going to be lightweight and portable, easy to set up and tear down at the end of the night, and then also affordable. And as I mentioned earlier, I'm not going to talk about pricing. So everyone you're free to make your decision as much as you want. So I started looking at star trackers, because usually that's what most people recommend when it comes to getting portability, if you will. So there was the Ioptron Sky Guider Pro, as well as the Skywatcher Star Adventurer. I was a little bit iffy on them, and the reason why is because I am lazy, if you will, when it comes to finding objects in the sky, and especially if you're imaging from the city. The odds are you can only see a handful of really bright stars, and so you're a little bit captured. I'm sorry, the word I'm looking for is restricted by what objects and how you can find objects in the sky. So I wanted a go-to. So eventually I settled on Skywatcher's new mount. Well, it's about a year or so or more on the market now, and it's very under the radar. And it's called the Skywatcher AZ-GTI, and it's a really nice mount, and I have it here, and I'll show it to you in a second. It has full Wi-Fi control, so you can control it with your phone. It has an 11-pound capacity, which is great. It has the go-to options that I wanted, so then that would allow me and also be able to do long exposures. It even also has an auto-guiding port capabilities where you can auto-guide when you're taking long exposures. So as the Earth rotates, your mount is also rotating, and then also you can send signals from your computer to the mount. And I scored big time. I got this, again, on the used market. So I had to do some modifications to get it into ready for what I want to do. And so it is an alt-as mount. So it doesn't track the night sky per se, especially when it comes to looking for long exposure pictures. So what I did is I had to purchase an iOptron base, and there are other bases, EQ bases, equatorial bases that you can buy. I settled with the iOptron, and that's it there. So I put it on top of the mount, and then, on top of the tripod, and then the mount on top of that. I also had to get a counterweight system for it, to be able to balance my rig, and then another little adapter. And then I also made the modifications here with the plate. I didn't like the original plate that it came with, so what I did is I went through and I had a spare clamp, which is both Lost Mandy and Vixen, so the V and the L type mounts, so I can use it back and forth depending on what I have on the go. Now, going out to Long Sault and as well as to our CD Star party here at Bayview and Shepherd, I really realized that I'm going to need power as well. So I looked into what I can take with me on the go, and I looked into these kind of guys where these are power banks that you can take. They're pretty cheap, relatively cheap, but not a lot of power, because you're going to be powering your mount, your telescope, your mount, your computer, your dew heaters. There's a whole bunch of things you're going to be needing power for while you're in the field. So you're going to need a decent amount of power. I also look into these kind of things where they're very good power, but they're very expensive as well. So the solution I came up with was I made my own power box. And so what I did is I bought a 95 milliamp hour deep cycle battery from Costco, and then I bought all the parts off of Amazon and made my own battery pack. And then one afternoon, I just watched a couple of hours on YouTube. I've never done anything electronic like this in my entire life. I like tinkering, but not when it comes to electricity. Something that I stay away from, but I had no choice. So I did some research in it, and then with one afternoon, I sat down and then did the whole project and finished it off. And then a few months later, I bought 2 more batteries, and these ones were used as well, and they work really well. So these are 2 AGM 20 amp hour batteries. These guys here will probably last me for my entire rig, not including the dew heaters, probably 2 nights of imaging in those two small batteries here. So it's a great way of getting into it. So this is just a snippet of the actual setup. So here is the lens, the 135 millimeter lens. I'm using recycling, I should say, is my original ASI 1600 ZWO camera, which is a monochrome camera here. And then I have the filter wheel that's attached to it, and everything is on a dovetail. Now, one of the things I realized as I started testing is these kind of lenses are very touchy when it comes to focus. Sometimes they're either in focus or other times they're not in focus. And there are many times when I went out to Long Sault, for example, I took 2 hours worth of data, I got home and I'm like, oh no, my focus was off and therefore I have to throw out the entire night's worth of work. So I said there has to be a way of coming up with some kind of a way of having an opportunity to be able to have autofocusing attached to it. So what I did is I went online one afternoon, I like YouTube, and I did some research and realized that there are a lot of guys out there who are imaging who are using this little project called the MyFocuser Pro 2. And the way it works is you would buy an Arduino, just like Jim uses an Arduino in his projects. So I use an Arduino computer that's in the bottom of here, and then I attach what's called a motor shield. And the motor shield allowed me then to be able to attach a little stepper motor to it. And then I attached then with a belt and a pulley system here to be able to control the entire thing in the box here, which is the Arduino and the motor shield, and be able to control it with my computer. And so I can even run an autofocusing routine on my computer, which will take care of the focusing for me. So I can pretty much just set this up and go back to the car and warm up if I wanted to in the middle of winter, and let the computer take care of the rest for me, and then go from there. So what I did though is everything I bought standard, I did splice the wires here and put some connectors. And then I also had to create my own belt because most of the times you can find belts, they are made for people who have 3D printers. So they're much longer than what I needed. So I bought a kit that came up that came with a pulley system. And then I literally took a needle and threaded it and just stitched it together. And then I took some crazy glue and put it over it. And so the crazy glue soaked into the thread. And then I gave it the strength. And I'm happy to say that the entire project for autofocusing cost me less than $100. So I'm very happy with that. It keeps the cost down. And then now I can put more money into something else. So here's the complete setup here. So this was on my balcony the first time I got it, so the motor is not attached to it. I did put in an auto-guiding system originally on it, but I had some issues with the system. Because it was made as an alt-az mount, it's not necessarily, the gearing in it is not made for astrophotography. So I realized by testing that even though I've had issues with auto-guiding, and some people who have the mount have been fine with auto-guiding, I just gave up. I realized that this thing is actually pretty good because I can get up to 2 minutes or even further, longer exposures with no auto-guiding, just pure having it just track. And it does a really good job in tracking the night skies, which I wasn't expecting for, so it's bonus points for this little mount. And this is me here last week at our Millennium Square party. These pictures were taken by Peter Visma. So you can see how quite small the whole setup is, and I do have it here. I can show you. So if you're getting into astrophotography and you want to keep it on a budget, you can use APT, which is the astrophotography tool. It is nice and free. I like free. And it's great for someone who's getting started and just wants to get their feet wet into having a system that controls your camera, controls if you have a filter wheel, controlling that as well. Whereas some people prefer using the viewfinder. Let's say you're using a DSLR camera. Some people prefer using the viewfinder for looking at their images while in their field. But if you're taking let's say you have a one-shot color camera that has a filter on top of it, the odds are you're not going to see that many stars when you're trying to focus on those things like that. Whereas if you were to use a program like this, it can pick up a lot more than your eyes can do. And then later on, as you progress, you can look into things like Sequence Generator Pro, which is what I use predominantly these days. I absolutely love it. One of the best investments that I've made. And then also, for polar alignment, which you can do on this mount even without a polar scope. And the way you would do it is you would actually use the main camera as your polar scope. So it pretty much doubles as it. Now, one of the things is about SharpCap Pro is it will use, you can only have up to about 400 millimeter focal length. So you won't be able to do your polar alignment with, let's say, your main, if you have, let's say, a longer focal length telescope on it, or even a longer focal length lens, then you may have some issues. But at 135 millimeters, you're perfect, you're good. And I believe this was about $20, so not too expensive at all. Free again. There are programs for when it comes to stacking your images at the end of the night or whenever it is that you get around to doing it. The Deep Sky Stacker is really good for stacking your image, and then later on you can go into things like Photoshop or even a free program which is kind of related to astrophotography called GIMP. And then as you progress, in later on, maybe a year down, 2 years down the line, and you want something more robust, then you can probably look into something like PixInsight, which I absolutely love as well. That's probably the second best investment that I've made, and it's great. Not cheap, mind you, but great. So the results of this little system that I have put in here. So I have here the Sadar and Crescent area. I took this at Long Sault back in July, and this image is a mixture of narrowband filters. So we have both hydrogen alpha lines of data and then also sulfur 2 lines of data. And then I had taken oxygen 3 as well, but I had to throw that data out because of bad focus. So once I had all my focus issues taken care of, I went back and got the data for the the oxygen 3 and mixed it in with it. So when you're looking on here, the picture is the brown stuff that's all the way out here. That's all hydrogen alpha. The blue stuff is oxygen 3, and then the kind of yellowish stuff here is your sulfur. And then here is the Heart and Soul Nebula, again taken at Long Sault at our Deep Sky Deep Sky Star Party. And again, when it comes to wide field of view, this is what you're going to get. If you were to take this picture in an SCT, let's say an 8-inch, you'll probably be getting about this much in your picture. And in a refractor, 80 millimeter, probably just about the part of the heart. And then with a 135 millimeter, you're going to get the entire complex in here. And this is it in hydrogen alpha as well. So this guy here has actually become one of my favorite objects. This is called the CED 214, and it's a really nice complex because it has this little companion guy that's right over here. And this is actually called the Skull Nebula. And the reason why is if you put it in a certain orientation, it actually looks like a skull. So we have the mouth here, there's a nose, the eyes, and then there's this here. So that's a skull. So I really like that guy. And then we have the entire veil complex that can fit into 135 millimeter focal length here. So we have the eastern veil, the western veil, as well as Pickering's triangle in here as well. So that's in a nutshell, my presentation. I have been bestowed on myself quite a few accomplishments over the last year or two, and just thought I'd like to share. So I got the jury selection on the Imaging the Skies contest last year. by the RASC, and for my Sagittarius star cluster image that I'd taken about almost 2 years ago, which is actually printed in the plaque that I got. And then I got published in the RASC journal for the first time back in the winter, springtime, for my Horsehead and Flaming Star Nebula in monochrome. And that was taken from my balcony here in Toronto. And then also in August, I also got published again in the RASC journal for my M42 image, again taken from my balcony. This one actually took me quite a bit of time. I actually took about 3 months to gather enough data. And the reason why is because remember, I'm on the balcony, so I have a balcony in front of me, on top of me, sorry. Then I have what I showed you, the buildings next door, and then I got trees all over as well. So my window of imaging is quite limited. So what I would have to do is wait for Orion to come out at the end of its trek. So when people are imaging Orion now in October, November, I have to wait until January for it to come completely over, flipped over, for me to be able to get some data. So it took me quite a few months to get enough. So this is almost, I believe it was almost 12 hours of data and over many, many nights of collecting it. So I'm very happy with this picture. And thank you very, very much to the RASC for publishing it for me. And then also I got bestowed the Ray Thompson Award back in our RASC Toronto picnic by our president, Ralph Chou. So I'm very happy with that as well. I've been busy, as you can see. And then I presented a talk on Pix Insight back at Starfest of 2019. And that same night, I got first and second place in the imaging contest at Starfest, so I'm very happy with it. And I'm happy to say, too, that this picture of the North American Nebula and the Pelican Nebula was taken with this setup. So I'm very happy with that, and that's a picture that came first. And the second picture is the Lagoon and Trifid Nebula. That image was taken with my refractor telescope, the 80 millimeter. That was taken last, so 2 Starfests before that. So what about you? If I can do this, anyone can do this. Honestly, we're restricted with our night skies here in Toronto, but we try. I have to take what I'm given and hopefully make lemonade with it. So if I can do it, I'm quite sure anyone else can do it. The sky literally is the limit. So you can come on out if you are interested in astrophotography and you're in the center or you're watching this online and you're into the Toronto area. By all means, come out to our different events that we have. We have our Dark Sky Star Party at Long Sault Conservation Area, which is near Bowmanville, Ontario. And then the week following that is usually our City Star Party over at Bayview and Shepherd. So by all means, come out. I'm usually there because I'm the observant chair. Most times I'm there. So if you want to talk, or if there are a lot of imagers as well, especially at our Dark Sky Party, where you can just shoot whatever ideas that you may have or questions that you may have. And that's the end of my presentation. I just want to say thanks to my wife and son for their continuous patience with me through the nights when I go missing for a night, as well as Penny and the Astro Goonies. They know who they are. And then also the Toronto RASC. That's it. Thank you. So I'll just show you the setup here before we take in here. So the whole thing is right here. It's quite light, easy and simple. And as you can see, it pretty much, I would probably say maybe about 10 pounds, 15 pounds for the entire thing. And it works really well. Questions?
Just a comment online from Blake Nancaro. Mm-hmm. He says, Adrian, well done on the night shield.
Oh, thank you. Yeah, it's that night, the shield has been a saver because I noticed when you're taking pictures, especially with Sequence Generator Pro, it tells you how much exposed your images are as they come into your computer. I noticed a major difference when I didn't have the light shield on versus when I did, because the light was coming straight into my objective. And anyone who knows anything about that, what happens is then you get a higher readout of your images, as well as you get reflections in your pictures. So putting up the light shield definitely helped for sure. Any other questions?
I have a question.
Yes.
First of all, congratulations on your achievements, accomplishments, and
Thank you.
great images.
Thank you.
I wanted to ask about your lens. I noticed that it's an f2,
Yes.
which is quite fast.
Yes.
Are you getting sharp images right to the edges?
I don't shoot at f2. I shoot at f2.8.
Okay.
And if it's a really bright object, I sometimes go to f4. The reason why is there is some issues at f2, especially at the corners. And it's even worse if your focus is off. It looks like you have a lot of marbles in your pictures. So I shoot at f2.
Okay.
Yeah.
F2.8?
f2, sorry, f2.8, yes.
Very good.
Yeah, go ahead.
Another question from Blake. Firstly, he says amazing. And second thing you mentioned is, did I miss it? What software do you use for polar alignment?
I use SharpCap. So I use SharpCap Pro. It was about $20 US, I believe. And I'm up and running my polar alignment within less than 5 minutes. It's really easy and simple, the routine that they have. Whomever it is that created that program, kudos to them, because they did a really good job of making it very simple for anyone can use. Yeah. Okay.
Any more questions? No?
All right. Thank you.
Whoops. Okay. We're using the Wayback Machine, 2019. Okay, well, I hope, sorry, normally I would be the first to present, but I'm not. It was a bit of a trying day today, so hopefully everything is here and everything's going to work out okay. The sky this month, where are we? So we're heading towards Samhain. I thought rather than talking a little bit about, dates and times and so on, I would just sort of note that October 31st is a special day because it's halfway between the equinox and the solstice. And there's a bunch of other days, including from Celtic lore. So that's Samhain, and we've got Imbolc and Beltane and Lugnasdad in August. and it's interesting because you might recognize some of these dates as obviously Halloween, October 31st. February 1st is not only my birthday, but it's also one day before Groundhog Day. May 1st is May Day. And for some reason, August 1st is the long bank holiday weekend. It doesn't have a real Celtic tradition behind it. But all of those dates that represent the midpoints between the equinoxes and solstices have been celebrated for a long, long time as important dates in the turning of the year. So we're kind of, halfway between the equinox and the solstice when we get to October 31st, and then we further subdivide it into these other in-between points, and I believe that the pagans just had a really good sense of, okay, well, it's probably time for another party. It's been 6 weeks. So anyway, that's where we are. So in where we are in terms of the solstice and so forth is that we are, we're seeing astronomical twilight now quite long, from 8 o'clock through to almost 6 o'clock in the morning, and we're losing about 2 minutes of daylight a day. It'll slow down as we get closer to December and almost come to a complete halt right around the solstice. This is prime time, so we're getting to the point where things are getting dark early enough to really do things with, and yet it's not yet so cold that it's difficult to get out and difficult to use your equipment. So this is good times, and good times to be enjoyed. In terms of the big picture, so I always like to start out with this picture here from moonwise.co.uk, because they do a very good job of showing off the entire night sky as you sort of see it going from left to right. So I'm just going to, starting here. So this is the sky, the sun as it sets, and the planets along the ecliptic are shown here, essentially in a straight line, and you can sort of see where everything is. So what we notice is we've got the inferior planets hanging out around the sun, Saturn, Jupiter near the sun, Neptune, and the full moon, which is near mid-month, right, showing up here. Then we've got a bit of a pause through the morning sky before Mars eventually shows up here in the morning sky. So that's roughly where everything is. And you can see at this time of year we've got some of our key constellations, the Great Square of Pegasus. Taurus is coming up around the middle of the night. Orion's starting to become more accessible. And we still have a lot of the summer constellations in view. As you probably all know, we recently had the annual planetary awards, which everybody here, I think, saw on TV. There wasn't a lot of surprises. The largest planet award, again, went to Jupiter. That's 4,485,480,000, lots of consecutive wins. Jupiter's really been knocking that out of the park. Most impressive rings, Saturn also, 7 million impressive consecutive wins for them. And of course, we also have the largest number of moons, Jupiter with 79, but wait for it, no, Saturn has just come in with 82. So, something new in the planetary awards. So, what's interesting, I read this article from Nicole Montalero. Scientists have discovered a whole new batch of moons around Saturn, which has lifted it into first place. This is expected to potentially be temporary because the nature of these surveys is they're finding 1 to 5 kilometer moons in deep space, figuring out their orbit and figuring out that they're actually captured by Saturn's gravity. There are interesting alignments being found there because of planetary alignments. There's an Inuit group which is following one sort of set of orbital paths, and there's some other ones. I think, though, that Saturn's award may be short-lived because if you think about it, Saturn is twice as far away from the sun as Jupiter, so the relative space that you're looking at to find moons for Saturn is roughly here. The relative space you need to look to find the same number of moons for Jupiter is like this much bigger. So I suspect that Jupiter might just jump out in front again. So we'll find out at the next planetary awards show as it comes up. So just recapping a little bit in terms of what we've got with planets this month coming up. Jupiter is heading out. I saw it tonight on my way out from home. It's there. You can get a telescope on it kind of right at sunset, but it will be dropping very quickly over the next few weeks. So I'd say it's almost gone. Certainly it's going to be in the muck very soon. Saturn is following it directly, and it'll be almost gone soon. Neptune is kind of in its prime position. It's at near opposition. It's as good as it gets. It's a very small but very blue planet, so if you can get a telescope on it with relatively high magnification, you can easily pick it out if you're looking in the right spot. And Uranus is up there as well. It's rising a bit later than Neptune now, and what I'm seeing is that Uranus on its inside track, its orbit's about 80-something years. Neptune's about 170. What I've been noticing over the past few years is that they've been really starting to show some distance now between the two planets. It wasn't that long ago, about 10, 12 years ago, that they are actually really almost one on top of another, and there was a close pass of Uranus and Neptune. Now we're seeing Uranus really moving into a different part of the sky. So it's kind of doing the same kind of behavior that we're used to seeing from Saturn and Jupiter, only, you know, in slow motion. Venus is an evening object, twice as evening as I was expecting, and Mars and Mercury pretty well lost in the solar glare, and we'll talk a bit more about Mercury in a minute. Moon phases this month. We've got full moon coming up around the Thanksgiving weekend, so that's next weekend. Good observing weekends will be around between the 21st and 27th. There's a full moon, or our last, I believe, supervised weekend at the CAO is the end of this month. So put that in your calendar. Good opportunity, hopefully, for some observing. And then before our next meeting, we'll have the first quarter. Now, I mentioned Mercury because in my sky this month, not the next sky this month, but in my sky this month, we have a transit of Mercury coming up on Monday, November 11th. That's 2 days before the next meeting. So we'll probably be hearing lots and lots about this over the next month. I expect this to be something of an observing event. There'll probably be some activities. I'm sure Ralph's got some ideas about that, and keep your eyes peeled on the center chat rooms and so forth to find out more about that. So this is the specifics of Toronto's experience here. So I've got a couple of things here. So one is, you know, the azimuth direction. So if you have any trouble figuring out where the sun is, right, you can use a compass, and you can use this to identify exactly where the sun is in the sky. Hopefully not too many of us have trouble with that, but of course you're going to be using safe solar filtering. But the key thing here is just the sun's altitude. So this is another month from now. The sun is starting to get pretty low in the sky, so you can see even heading right towards local noon, the sun's only up at 27 degrees. So when you're planning for this, you got to be thinking, okay, that sun's going to be tracking low, so you're going to need a good horizon to the south in order to see this event. The other thing is, if you want to see transit start, you have to do some really good preparation, because the transit start is when the sun is only at 4 degrees. So 4 degrees is like roughly, you know, a couple of, you know, finger widths over the horizon when held at arm's length. So that's really close to the horizon. Not quite as close to the horizon as a transit of Venus was back in 2004, but I think you're going to need a similar, if you want to catch the transit starting, you're going to need a similar really perfect horizon, probably over water, to see it. And the transit, the partial to full transit takes about a minute to happen, so you need to really have eyes on it and be ready to go at that time. There's a couple of marks here. There's the sort of mid-transit is when it's nearest the center of the sun, and the full transit will end, and the partial transit, it moves right off the sun's face just after 1 in the afternoon. So from a public, that's the word I'm looking for, outreach perspective, this is an interesting opportunity to bring your solar scope to work and wander out into the parking lot around 11:30 and say, hey, come on out and check out the transit of Venus / Mercury, sorry. And you know, you would need relatively high magnification too. That's the other thing to point out. Mercury is really small. It's further away than Venus. It's smaller than Venus. So if you're looking for, like, Venus really look like somebody took a bullet hole out of the sun. Mercury, you really need to kind of keep an eye for it and close. This really excellent simulation from timeanddate.com shows what the relative size of Mercury versus the sun will be. You will be missing those helpful pointers in your scope, so it's going to be that small. And I don't know, currently the sun's very quiet, so there's not a lot of sunspots going on, so there might not be much else to focus on, so you will need a chance to look at it. And I'm just going to see if I can launch a... Do we have internet access on this computer? Yeah. Great. I'm going to see if I can get, whoops, the animation to run that I took this picture from here. Whoops. Back. And it would have been a hot link if I'd been better. Hang on a second. I'm just going to bounce out of here. Grab that link. Copy. Switcheroo. What's that? Okay, there's a browser. Let's see. Okay, let's, oops, did I? There we go. Okay, good. Nice, okay, great. So this is an animation here, I'll just start it again, of the transit sort of essentially in progress here. So there it goes. So you can see how it's following along the sun. So it kind of looks like it's starting off on a straight line like this, but what's interesting is it's showing you sort of the orientation. So as the sun sort of twists its way through the sky, the path of Mercury sort of peels off towards the edge like this. That's the midpoint, that's the closest it gets, and it gets very close to the middle of the sun for this transit. And then it keeps on trucking and trucking and trucking, and will eventually make its way right off the sun. So, and you can see here the sun's altitude peaks at 29 degrees. So that's sort of our best one there. I'll just run it one more time. Oh, it'll run itself one more time. There it goes. And it's just highlighting it's pausing at the moments there. Now, one thing that's interesting about these transit always is if there's any prominences or anything else like that going on at the edge of the sun, sometimes you can get really lucky and catch the silhouette of the planet against a prominence before it actually hits the edge of the sun if you have a hydrogen alpha scope. So that, I don't know if many members have that equipment or have that ambition, but that's something that people might be able to take advantage of. Or at least we should see some of that on the interwebs after the event. So that's a preview of the transit of Mercury, courtesy of dateandtime.com. A very useful site. I find they've got lots of good stuff there. All right, where is my cursor? Moving right back to our slideshow. And skipping ahead. Okay, so we had a quick look at the transit of Mercury. Now, a little bit of fun facts. Transits of Mercury always occur either around May 8th or November 10th. And if you remember your basic eclipses, a transit occurs when the elliptical path of planet A intersects the elliptical path of planet B. There's two places, one where the planet appears to be coming up and one where it appears to be coming down. So May 8th is the ascending node, May 10th is the descending mode. And because Mercury goes around the sun way faster than Venus does, there's a lot more opportunities for transits. And so the lineup occurs approximately every 4, 6, 7, 13, 33, 46, 171, or 217 years. And the geometry of Mercury transits is such that every 217 years, the transit path follows almost exactly the same path. So there's essentially sort of a canon of transits where the transit will go through the northern hemisphere, go through the southern hemisphere, and so on. So every 217 years, it lines up exactly the same way, and the next transit along that will look exactly like the one in November will be in many years from now. But the next transit in the of any kind for Mercury is also in November, and it's 2032. So for a lot of us, this opportunity may be like we had one, I think, about 4 or 5 years ago, relatively recent. So this next one is one of these integer ones where it's a significant number of years away. So this is one of those 13-year gaps that happen. So all of that is excellent and very interesting, but it's November, it's Toronto, it's probably going to be clouded out. So anyway, I'm glad I told you all about that. We can all appreciate it. In terms of what's going on in the sky, we're heading into the water constellations. So we've got Pisces, a fish, Cetus, a whale, Aquarius has water jugs, Capricornus is a sea goat, and we've got the southern fish because the northern fish was feeling lonely. We've even got Delphinus up there, which isn't really part of the water constellations, but is a dolphin. The horse is presumably splashing in the waves there, and it's part of some kind of a commercial or something like that. Anyway, what's interesting about the water constellations is that this is absolutely a pause in the sense that there's very little going on in the way of deep sky objects at this time of year. And what we're looking at when we're looking south in the fall is we're looking at what they call the Messier hole. So every year there's an opportunity for a Messier marathon where you can see all of the Messier objects in one night. And the reason for that is that when the sun moves its way along the ecliptic and ends up in this area with the water constellations, there's actually no Messier objects around there for the sun to wash out. So that creates the opportunity for the Messier marathon. So when you're casting around in the fall trying to find something interesting to view, take heart. The Messier marathon is coming in just about 6 months' time. In terms of targets, so the key constellations that have got some good things, Pegasus obviously is your pointer to Andromeda, the Andromeda Galaxy. Taurus, we have the Hyades cluster, and Perseus is in the north now, high enough to see the double cluster, the Alpha Persei Association. Cassiopeia has a nice selection of galaxies and other things around it. And not to give up completely on the summer objects, the summer triangle is still visible in the west. As the nights get longer at this time of year, the apparent movement of the stars seems to sort of slow down. So the sun is setting faster while the stars are moving in their paths, so we've got a little bit more time to see those southern objects, and we don't have to give up completely on the summer triangle actually until December. In terms of other events to see, besides the usual things, we've got a couple of specials here. There's a comet that might be visible and an occultation I'd like to tell you about on October 30th. So the first one to tell you about is Comet Africano. So this one here, this is a finder chart taken as of Monday night. So this is from Toronto. And what's interesting about this is that this is was right around Neptune here. So if you remember from my earlier sky chart, that's right in this, Neptune is right now at opposition. So it's relatively in the middle of the southern sky at midnight, and so, and available. Now Africano is heading towards the southern sky. So this is kind of like a target of opportunity. If you wait until the moon is out of the way, it will be gone. And it was, at least in terms of this area here, it was roughly, near Neptune, which would have given you something there. I've got a web reference here. We'll have a look at that afterwards, just to see if we can find out where it is tonight, in case anybody wants to go and have a look. But it seems to be about the only good comet that's roughly about 10th magnitude. So you need a relatively good telescope to pull that out. On an easier note, we have an upcoming occultation, which I would like to invite everybody to, because this one is actually pretty good. We've got a 6th magnitude star, which is really pretty bright. Typically, we're dealing with 8th, 9th, 10th magnitude stars. 6th magnitude is like Florida. This is warm and sunny, and it's actually even easier. Like, it's actually occulting a Hipparcos catalog star. So Hipparcos catalog stars are easy to find in your planetarium program too, because they're usually well cross-referenced. Every planetarium program I've ever seen has generally got the Hipparcos catalog loaded. So you can just punch in that number 44575 and find the target star very easily. Elevation's 39 degrees, which is about halfway up the sky. The duration is up to 2.5 seconds, and it's a 9 magnitude drop, which means it's basically going to go completely poof. There's only one drawback in all of this goodness, which is that it's at 3:30 in the morning on a work night. But you can see the path here. It goes through, pretty well runs right over Barrie. Hey Blake, FYI. The Carr Observatory is near the northern path. A lot of our accessible areas here are right on, this is like Forks of the Credit area here, near Minto and so forth. So this is potentially very observable. There's already 3 observers signed up for it on Occult Watch. I expect we'll see a lot more because this is kind of going over prime area here. And one thing to watch out for if it's changing is that the path can always shift a little bit. So this is based on the most recent astrometry of the asteroid and of the star. And so while they're getting more, the error bars get tighter, there might be some final changes and move it a little bit either way. Anyway, if you have the ambition, this would be visible in your eyepiece, easy to find, and it could just disappear on you if you're in the right spot at the right time. Other targets, I think I mentioned a lot of these. One thing that is kind of cool at this time of year, Algol is in good viewing aspect. Near the new moon, we've got 2 sort of minimum opportunities. So Algol, for those of you who haven't heard of it before, it's an eclipsing binary star that goes on a regular pattern about every 2 and a bit days. And what happens is it's a double star system, and a dimmer star passes in front of a brighter star, and the whole system drops in brightness for about 3 hours. So it's quite a noticeable drop in terms of its brightness, and it was something that even ancient people noticed a long, long time ago because it's close to other stars that are relatively bright. So there's 2 opportunities coming up at the end of October where that minimum is going to be in prime observing time. So those are good opportunities to make a note and to see if you can go out there and compare and contrast Algol with its minimum versus maximum. And when you're looking for it, Algol is here Beta Persei, and it's essentially, this is Perseus here. Merak is the brightest star in the middle. This is the Alpha Persei association, and you're going to be able to compare Algol at its brightest is going to be brighter than these 2 stars here, and at its dimmest it goes down to 4th magnitude roughly. So it becomes noticeably less bright than these ones here. So something to look for. IAS spotting happening as usual. This month we'll have some evening passes until October 11th. In fact, there was a great one tonight at about 10 minutes to 7 before the meeting. So I was thinking, oh great, I can highlight this great pass, but then everybody will already be in this room by the time that great pass happens. So that's not very useful to anyone. But then morning passes will resume on October 22nd, so we have a bit of a break until between October 11th and 22nd. The best one I could see for the month coming is October 26th, around 7 a.m., 82 degrees up, which means it'll go pretty well straight overhead as seen from Toronto. So, and it'll be commensurately bright at that time. So that's something else to look forward to. So that's what I've got for everyone tonight. Pause and ask if there's any questions, or even better, comments, anything I've missed, anything else that anyone else would like to highlight. Oops, not that. Yes, sir, Andrew. Adrian, sorry.
The occultation of, the transit of Mercury across the sun, how long is it going to last?
It's going from 7 in the morning. We're actually seeing it at its beginning. We actually see the whole transit from here until 1 in the afternoon. So that makes it out about 6 hours. We're just on the edge. If we were a little bit further east, like New York City or Newfoundland, we'd have a better view. We'd have it well up when the transit started, and it would still be up when it's there. But we're, all things considered, not bad. Yes, sir, Tom.
One suggestion for observing site for the Mercury transit would be the same beach that we used to observe a dawn solar eclipse many years ago. There's a parking lot at Woodbine Beach right by the water's edge, which would give you a view right at just after dawn, all the way through the entire transit.
Nice. Okay, so Woodbine Beach is a good potential observing site. And with that direction, you can scout it out in advance and make sure that the sun's going to come up in a good spot. I'm assuming that you're going to be watching, right? Mercury Man? Any other questions or comments? Once, going twice. Okay, well, thank you very much, everybody, and happy observing.
Okay, before I actually launch into the into the announcements, I just want to comment that the last couple of weeks we've had an awful lot of education and outreach programs going on. Hearty congratulations to our Durham outreach group who concluded their Millennium Square programs last Friday night with a very successful evening. We also had a lot of stuff going on in conjunction with, first of all, the 50th anniversary of the Science Center on the 28th and 29th of September. And then, of course, with Nuit Blanche, we also helped out there. So the Science Center hosted something close to 40,000 people on the weekend of 28th, 29th September. About 20,000 each day, and we were down in the corridor between the escalators and the Space Gallery on Saturday, and then out on the solar patio on Sunday, and we saw our fair share of visitors. So those days were very, very busy. And then on Nuit Blanche, the group saw something like 900 visitors to our telescopes as they wended their way into the special display in the Valley Building. So thank you to all the people who are involved in that, because it really made a big difference. And the Science Center has sent us a message of thanks for our contribution to those programs. So again, thank you. Okay, let's take a look at what's coming up with various programs. Our next meeting in 2 weeks is a speaker's night, and our presenter that evening is Dr. Isaac Smith, who's with the Lassonde School of Engineering at York University and their Planetary Sciences Division, and he'll be talking about a high-resolution view of icy Mars. And Tom Luton is going to be doing the honors because I'll be away that week at a conference. 3 weeks after that, we have a bit of a gap. Instead of 2 weeks, November 13th is our next Recreational Astronomy night. And the program, we've got Andy Beaton returning to present the sky this month. Ed Trez is going to talk about a cruise and a collection of conjunctions. And then Chung is back to give the talk on emission nebulae imaging that he had originally been scheduled to talk about tonight. So we're looking forward to hearing Jim that. Solar observing, the next regular session is on the 9th of November, just ahead of the transit, so it'll be a good warm-up, as it were. And Sean will give the usual go and no-go messages on either Friday late afternoon or Saturday first thing in the morning to let you know whether it's a go here at the Science Center. Our regular evening star parties, Adrian's already mentioned them, and so has Denis, but we've got those towards the end of the month. Dark Sky Star Party, the first clear night of the week of the 28th of October through to the 1st of November at Long Sault. And then our City Star Party the following week, first clear night between the 4th and the 7th of November. And again, the go or no-go will be issued through our usual channels. Also on the 9th of November, we have the second of our outreach events that coincide with closing times at the Science Center here out on the Telescape. Between 6 and 8 p.m. On that Saturday night, we'll be looking to show the sky off to people as they're leaving the Science Center at closing time. And this program worked fairly well last winter, and we're looking at continuing that through this winter as well. We will do a go or no-go in the mid-afternoon and then set up around just before 6 o'clock to present this. The next outreach event at the David Dunlap Observatory is an astronomy night with our own Dr. Roberto Abraham as the guest speaker, and that'll be on 19th of October, starting at 7 p.m. And again, you can either go up to hear Bob do his presentation, or better still, volunteer and help out. Again, the DDO committee can always use some additional assistance with those programs. Talking about volunteers, we have a new program to help foster volunteering, and among other things, we are providing a way of getting connections to the various programs that do need volunteers. Also, for some of our programs, we can arrange for a vulnerable sector check for police record checks for people who are doing outreach presentations and so on with youth groups and so on. And again, this is all being managed through our volunteer coordinator, Blake Nancuro. And also another thing to remember is that we have our own dark sky site where you can practice your imaging and so on in a fairly isolated area up at the Carr Observatory. And we do have, among other things, the new SLO for imaging, and you can book time on that telescope when you make your reservations. You can also borrow telescopes, and we've got a new addition to that collection. So we have telescopes available that you can arrange to borrow for a couple of weeks at a time. And finally, for those of you who are inclined, we have the meeting after the meeting at the Granite Brew Pub down at Mount Pleasant in Eglinton, and some of us will see you there later this evening. So that's it. Thank you for coming out tonight. Thank you to those who are online for watching our stream, and we'll see you next time. Good night.